Okay, so just like the ones we were looking at yesterday, what we have to remember is that, yes, we can say that velocity is displacement over time, but as I was saying, that's kind of like the singular version of that formula. Okay, it can also mean this, that the average velocity over an entire trip is the total displacement over the total time. All right, so if I can find the total displacement over the entire trip and the total time over the entire trip, then I can find the average velocity of the elephants over the entire trip. So what I'm going to first do is break this down into parts, okay? Break the trip down into its sections and use this formula singularly to get all the information I need. Namely, I need displacement and time for each part of the trip. Once I have those, then I can find the total for the entire trip. Everyone kind of follow me there? All right, so in part one of this trip of herd of elephants here, okay? So in part one, the elephants walk for 1.1 hours, which I already said I want to turn into seconds. Okay, so I'm just going to go 1.1 times 3,600. So that's 3,960 seconds. Okay, at a velocity of 3 meters per second north. All right, in part two, okay, they walk 7 kilometers south. Okay, in 1.5 hours. Okay. All right, so 5,400 seconds. Okay, and then they walk at 4.5 meters per second for another 2 hours. Okay, and that'll be 7,200 seconds. Okay, so that's the information that I have, right? The question wants the overall distance traveled and the average velocity of the elephant. So it's asking for one thing that's scalar, distance, and one thing that's vector, the velocity. All right, so what I need, if I'm going to get either one of those things, is I need to know the total displacement, which means I need to know the displacement in each section. Okay, right now, I only know the displacement in part 2. Can I calculate it in parts 1 and 3? Yes, so that's where I'm going to be using this formula in kind of a singular form, okay, for these two parts here. So I'm going to manipulate v equals d over t to solve for d, which means I'm going to multiply both sides by t. Okay, so I'm going to have that d equals v times t, so that'll be 3.0 times 3,960. All right, so all right, so they're going to walk 11,880 meters. North. How do I know it's north? Right, it says that they were walking at a velocity of 3 meters per second north. It would be impossible to travel a displacement anything other than north if that's the direction you're walking. Okay, all right, so now I've got displacement and time for part 1. I have displacement and time for part 2, but I still need to find displacement for part 3. All right, so I'll do the same calculation here, d equals v times t. So that'll be 7,200 times 4.5. All right, they're going to walk 32,400 meters. North. Okay, so the first part of the question wants to know the overall distance traveled. Do north and south make any difference if I'm calculating distance? No, distance just wants to know how far did the elephants walk, period. Okay, so all I have to do then is take all the distances and do what, or all the displacements and do what with them? Just add them, regardless of whether they're north or south. All right, so that'll mean that we'll take that 32,000 and we'll add that to 7,000 meters, okay, which is how far they went there in part 2, okay, plus the, was 11,880 meters in the first part. All right, so our total distance traveled by the elephants is 51,280 meters. So you went 51 or 51.28. Okay, I would say in a question like this, we should probably reflect all of the numbers that we have. Okay, we'll talk about significant digits when you get into grade 11, but okay, so 51,280 meters, okay, is my total distance traveled. Now it wants me to calculate the average velocity. All right, well, average velocity is the total displacement over the total time. All right, so that's going to mean 11,880 meters north plus 7,000 meters south. How do I represent north and south mathematically? Yeah, positive and negative, all right? So I'm just going to add a negative 7,000 meters here. And then the other one, the 32,400, was also north, so I'll make it positive. And then I got to add all the times together as well. I need the total time. Okay, so that'll be 3,960 plus 5,400 plus 7,200. Okay, that'll give me my average velocity over the whole trip. Okay, so 11,880 plus negative 7,000 plus 32,400. Okay, there's my total displacement, 37,280 meters north. Okay, divide that by 3,960 plus 5,400 plus 7,200. All right, so I'm getting an average velocity of 2.25. What are my units going to be? Meters per second. What else do I have to put on here? North. Okay, it asked for a vector quantity. Velocity is a vector quantity, so I need to put the vector on that answer. Okay, now we kind of drew that out, made it seem like a really long question, but I mean, was there any really difficult math in there? No, not really. Okay, we had to do v equals d over t a couple of times, okay, and that was really about it. Okay, any questions on how that one worked? Okay, that's a pretty common question to get on a quiz or something like that. Okay, see them on worksheets all the time as well. All right, because all it's really asking you to do is do a v equals d over t calculation. Okay, just getting the hang of how to do that, and also demonstrating the importance of when is it scalar and when is it vector. Okay, and we do things a little bit differently if it's a scalar thing that we're calculating versus a vector thing we're calculating. All right, the other thing that this question is meaning to show you is the importance of matching your units. Okay, I can't divide meters per second by hours, and I can't multiply meters per second by hours because they're not the same thing. Okay, anytime I'm doing a calculation with v equals d over t or any of the kinematics formulas, if I have a velocity and a time, the time units have to match. If it was in kilometers per hour, I could leave it in hours. Okay, but because it was in meters per second, my time units have to be in seconds. They have to match what's in the velocity. Okay, so I want you guys to do just a little bit of kind of practice here and see how we do with this stuff. So from your the files that are on Google Classroom, one of them is the physics unit worksheet book, kind of like what you had for chemistry. There just wasn't one for bio. All right, and so that'll be, it's on page 2, I think. Yeah, page 2. Okay, so there's some velocity, speed, displacement, and time problems here. Okay, the answers are on there, so you'll know if you do them right. Okay, just kind of practice those a bit, and then we'll go over a few of them if there's any trouble. Okay, and we'll just do that for a bit. We probably won't do that for the whole class because I don't think we'll need to. Okay, but we'll just give a few of them a try for right now. All right, let's have a look at 12 here. First thing I'm going to do is have a column here for the whole trip. Okay, the average velocity for the whole trip is 40 kilometers per hour. Okay, and the total displacement of the whole, or the total distance, sorry, these aren't velocities, it's distance. Okay, oh, actually it is velocity because it says due north, not that it matters, but okay, so we have a 60 kilometer trip. If I'm going 60 kilometers at 40 kilometers per hour, that trip is going to take 1.5 hours. Everybody all right with that idea? Okay, all right. Then we have the individual parts of the trip. In part 1 of the trip, okay, we have an average velocity of 25 kilometers per hour. Okay, and that that is for 15 kilometers. All of these are north, which is why it really doesn't matter. There's no change in direction here ever. Okay. Then we got part 2. Okay. In part 2, it's 62 kilometers per hour. Okay, and that is for 32 kilometers. And then in part 3, all we know is that the last part is 13 kilometers. Okay. I have D and V for all of the parts except part 3. Can I find the times for part 1 and part 2? All right, so that's the first thing I want to do is find out how long are parts 1 and 2 going to take. So time equals D over V, which for part 2 is going to be 15 divided by 25. All right, so that's going to take 0.6 hours. Okay, and then I've got to do the same thing for part 2 here, okay, which is 32 divided by 62. All right, so that's 0.516 hours. Now, something with physics, okay, keep all your decimals until the very end. All right, I didn't write them all, but I'm keeping them in the calculator. Okay. Now, if these two parts take that long, and I know the whole trip is 1.5 hours, can I figure out how long part 3 takes? Yeah, all I have to do is add them up and then subtract them from the total. All right, so I'm going to take that number plus 0.6. Okay, that's the time for parts 1 and 2. Then I'm just going to go 1.5 minus that number, and that'll tell me how long part 3 takes. So it's 0.3838 hours. Okay, I'm going to keep all the decimals. I'm just not going to write them all. Okay, so the time for that one is 0.384 hours, which means now I can calculate the velocity for part 3. V equals d over t. It's 13 kilometers. It takes 0.384 hours. Okay, so the velocity for part 3, okay, 13 divided by the answer I got, which was the remaining time, would be 34. I don't know why I got 34.2 there, probably because I rounded off. Okay, so 33 point, we'll say 9, 33.9 kilometers per hour, not meters per second. All right, everybody with me there? I think I rounded off when I made the key. You shouldn't round off. All right, everybody all right with how that works? Right, so it's all just V equals D over T. It's just when do I have to use it? What information do I need to get? The questions can get pretty intricate, okay, in terms of their wording and, you know, kind of the puzzle pieces you have to put together to solve for them. But in the end, they're all just V equals D over T calculations. The math isn't difficult. The challenge is getting through the wording, and that's always going to be the challenge for you going forwards in sciences. Okay, the questions become more and more complex based on their reading, not so much on their math. Okay, and I think I've told you this, but like last year's diploma exam, people were reading like 2 pages of text to answer 2 multiple choice questions. Okay, being able to read and interpret information in order to answer a question is an important skill that you need to acquire. Okay, so we're kind of starting you out small, okay, with a question like this, so that when you get to the question about cathode ray tubes on the Physics 30 diploma exam that involves reading 2 pages of stuff that most of which is not important, okay, to answer 2 questions, you can do it. Okay. All right, so I want you guys to first take a little break. Take a 4-minute break, okay? And then we'll try some of the vector ones after that. Okay, if there's any questions or anything, I can come around and answer them here.